a worksheet for inverse functions. And so I want to I'm not going to do it all, but there's a couple of things that students were having trouble with. And so I want to really hit those. First of all, for those of you who might not have been in class and are trying to do this, you got to know what I wanted you to do. First of all, if I want you to find f of a. And if a is 2, if I put 2 in here, I get 2, the point 2 and 2 cubed is 8. So this is the point A, B. Now it says find the derivative. Well, the derivative of x cubed, or dy dx, would be 3x squared. And if you're going to put 2 in there, we would get 2 squared 4 times 3, or 12. Now to find the inverse of this, we swap the y and x, so it becomes x equals y cubed. Now, for trig functions, we want to make a triangle, but for this one, we don't need to. Now it says solve for y in column 3. So to solve for y, we take both sides to the 1/3, and we get y equals x to the 1/3, or cube root of x. This says take the derivative of this. So instead of taking the derivative of this, we're going to take the derivative of the original function to see if we can find the derivative of this other than, this one's easy enough to do the power rule on, but we're going to do it on here. So the derivative of x is 1 equals, and then we got the chain rule, because this is not x. So we do the power rule, which is 3y to the 2 times the derivative of the inside, which would be dy dx, because this is not x. So we have to say that. Now, if we solve for dy dx, as it says to do here, we divide both sides by that, and we get 1 over 3y squared is what dy dx would equal. And then if we replace y from what we had in column 5, so that's 1, 2, 3, 4, 5. If we use this for y, we get 1 over 3 times the cube root of x squared is dy dx squared. And so x to the 1/3 to the 2 is what we would thought it would be. 1/3 x to the negative 2/3. And finally, the slope of the inverse at b, now if this is a, that's b, the slope at b is the reciprocal of the slope of a. Now the slope at a of the original function was 12. So now let's find out the slope of the inverse at b. Well, here's the inverse. We want to find its slope, that's the derivative of the inverse, its slope at b, which is 8. So we're going to do 1 over 3 cubed root of 8 squared. So the cube root of 8 is 2. Squared is 4 times 3 is 12. And so we get 1/12. So the slope of the inverse at b, that slope is the reciprocal at b of the slope of a, at 2/12. So that's the idea of how this sheet's supposed to work, except when you get to the trig functions. Now I want you to do that one for ln to find the derivative of ln. So you try to do that one on your own. Now I'm going to do the sine. Actually, let me jump down to tangent. No, let's do sine. Okay, pi over 6. The sine of pi over 6 is 1/2. So our A is pi over 6. Our B for down at the end is 1/2. The derivative of sine is cosine. So it's dy dx is cosine x. And if we find the slope of the sine of x at pi over 6, we put pi over 6 in there, and we get square root of 3 over 2. So the slope of this at pi over 6 is square root of 3 over 2. Now, go back to the first column and swap the y and x to get the inverse function. So x would equal sine of y. Now, in this inverse function, the angle is y. The sine of an angle is a ratio. Sine ratio is opposite over hypotenuse. So that's understood 1. So I'm going to make a triangle. I'm going to designate this angle as y. And so the side opposite here will be x. And the hypotenuse will be 1. And I want to know what this is. Now, Pythagorean Theorem says leg squared plus the other leg squared that I want to find is 1 squared, or 1. So to find this side, I'm going to have to subtract x squared. So I'm going to get 1 minus x squared is this side, this unknown, squared. So I'm going to have to take the square root. That's the process to think about what that side's got to be. You've got to use the Pythagorean Theorem to figure out the unknown side. And you got to do it all the way down. I'll show you another one here in a sec. But let's follow this one through. So now, solve for y in this. So we got to get the sine off of this side. To do that, we do the sine inverse of both sides. So we get the y equals the sine inverse of x. That's an inverse function, and that's the one I want to find the derivative of. We should get it down here 3 columns later. Let's see if we can. So now it says take the derivative of this one. So derivative of x is 1. The derivative of sine of something is cosine of the something times the derivative of the inside, which is, since it's not x, we have to write dy dx. Okay? Now if we solve for dy dx, it's going to be 1 divided by the cosine of y. And if we replace the y with something that's in column 5, that's actually, or the triangle. And this is where we use the triangle. So dy dx is 1 over cosine of y. If we look at the triangle, y is here, the adjacent side is this, so that's square root of 1 minus x squared over, that's the adjacent, so your cosine's in the denominator, so adjacent over hypotenuse over 1. Well, the 1's not going to count, do anything, and something divided by 1 is just it, so this is the derivative of the arc sine. 1 over the square root of 1 minus x squared. And this will give us the slope of the arc sine. And it should be the reciprocal of the slope of the sine at pi over 6 if we do at 1/2. So the slope at pi over 6 was square root of 3 over 2. So here we should get the reciprocal of square root of 3 over 2 by putting in 1/2 in for the b in for the x's. So we're going to get the f inverse of 1/2 slope. And it's going to be 1 over square root of 1 minus 1/2 squared. 1/2 squared is 1/4. 1 minus 1/4 is 3/4. So this is 1 over the square root of 3/4, and the square root of, that's 1 over the square root of 3 is square root of 3. The square root of 4 is 2. That is the reciprocal. 1 over the square root of 3 over 2 is the reciprocal of square root of 3 over 2. It's also 2 over the square root of 3 if you want to carry it a little further. Multiply numerator and denominator by the reciprocal. All right, I want to draw the triangle for one more of these. Like, let's pick secant. Yeah, secant. Okay, I'll skip the point. I'll skip the derivative. I'm going to swap the y and x, so I'm going to get x equals secant of y. So now the angle is y. So I draw the triangle again with the angle being y. Now the secant is the reciprocal of the cosine. And so the reciprocal will be 1 over x. So the cosine has got to be adjacent over hypotenuse. So we've got to put adjacent as 1 and the hypotenuse as x. Or if you just think about it, if cosine is adjacent over hypotenuse, the secant is hypotenuse over the adjacent. Hypotenuse is x, the adjacent is 1. Now to figure out this side, we've got a squared plus b squared, we don't know that side, so I'll call it b squared, equals the hypotenuse squared. So to find b, I have to subtract 1, so I get x squared minus 1 equals b squared, and if I take the square root of both sides, I get this other side to be the square root of x squared minus 1. I'll do one more. I'll do the cotangent. So let's go here. So if I have the cotangent, then, and I swap them, I get x equals cotangent y. If I make a triangle, and this is x over 1, the cotangent is the reciprocal tangent. Tangent is sine over cosine, or opposite over adjacent. So cotangent adjacent over opposite. So adjacent to y, if y is here, the adjacent is x. The opposite is 1. Now to find this side, since it's a squared plus b squared equals c squared, and I'm trying to find c squared on this, the hypotenuse squared, it's going to be x squared plus 1 squared equals c squared. Then I take the square root of both sides. So I'm going to get the triangle, this side is going to be the square root of x squared plus 1. Okay, that should help you be able to finish the rest of the sheet.